Okay, inverse functions. Okay, so let's just take a look at the function 3x plus 5. So an inverse function just undoes the original function. So, for example, this function here, the value of x, is getting multiplied by 3. That's the first thing. And then we're adding 5. So if we want to undo all of that stuff, or do the opposite operations in the opposite order, for our inverse function, what we're going to do is, first, we're going to subtract 5, and second, we're going to divide by 3. So that would make our inverse function, which we represent as f negative 1 of x, would make it x, so first step, take away 5, second step, divide by 3. And you always apply like the second step to the whole thing you've just created. So the x minus 5, you divide the whole thing by 3, not just the x. Okay, let's look at another one. Say we had f of x equals negative 2x squared plus 3. You want to find the inverse of that function. So first thing that's being done to the x is it's getting squared. Second thing that's being done to the x is it's getting multiplied by negative 2. And the third thing is they're adding 3. Okay, so we're going to do the opposite operations in the opposite order. So for our inverse function, we're going to start with step 3. Except we're going to subtract 3. So we're going to have x subtract 3. Okay, second step, we multiply by negative 2. So therefore we divide by negative 2. Divide this by negative 2. And our third step, normally in the original we squared it, so in this one we'll square root the whole entire thing. Equal sides on the inside there, so that's weird. So just like that. And I did in class, like, I don't know why, but I feel like we don't always love negatives in the denominator, so you could also multiply the top and bottom by negative 1 and make that negative x plus 3 over 2. Same thing. Okay, let's try something slightly harder. Say we had f of x equals 2 over 3x minus 1. And we want to find the inverse of that function. Okay, so things that are happening to the x are, the x is you could do this a couple ways, but here's one way. The x is getting multiplied by 2/3, and then the second thing, it's getting subtracted by 1. So if we want to repeat those steps in the opposite order, we're starting with step 2. So we're adding 1. And then the first step, multiply by 2 over 3, now we have to divide by 2 over 3. So we take our x and we add 1 and then we divide by 2/3. But we couldn't leave it like that. That looks crazy with the fraction and a fraction. So we pull out our old fraction rules and we remember that when you divide two fractions, like 1/2 divided by 3/4, which just means flip the second fraction around. So yeah, we can do that, and it's easier to multiply. We get 4 over 6. So we're kind of doing that in this case. We're going to leave the x plus 1, and then since we're dividing by a fraction, we're going to switch that to multiply, and we're going to flip the second fraction, so we're going to multiply by 3 over 2. So you could leave it like that, or if you want to write it as 3x plus 1 over 2, maybe. Looks a little nicer. You could leave it like that. And that's how you do inverse functions. There are tricky ones like this. If you had x squared plus 6x plus 2, okay, we're not going to be able to do our steps because x is getting squared multiplied by 6 added by 2, but there's 2 x's, so what's being done first? You can't do it like that. So if you get an equation in this form, it's easiest to switch it to vertex form in order to find the inverse. And I'll just quickly do that. So I want to group my first two terms together, and I want to turn them into a perfect square. So I'm going to take my 6, divide it by 2, and get 3, square it, which gives me 9. So now I know I have to add 9 and subtract 9. And I want to pull this minus 9 out, so I've got x squared plus 6x plus 9 minus 9 plus 2. And then I'm going to factor this into x plus 3 squared, because there'll be 2 of those brackets, minus 7. So that's what it looks like when you put it into vertex form. And now if you wanted to find the inverse, you just have to do the opposite operations in the opposite order. So the first thing is it's being adding 3, the second thing is it's getting squared, and the last thing is it's getting minus 7. So our first thing is we're going to add 7. Our second thing is we're going to square root it. And our third thing is we're going to subtract 3. That's what our inverse looks like. One more thing about inverses, just quickly, is their graphs are reflections of each other along the y equals x axis. So that's just saying just draw something. You know, if you had some, like a parabola that looked like this, and you wanted to graph its inverse, you could just flip all the coordinates. So here we have a coordinate at 2, 0. So in the inverse, that would become 0, 2. So that point would appear right here. Then this, we have a point at 1, 1. So that would actually stay at 1, 1. So you would have a point right here. This point here at 3, 1 would become 1, 3. So 1, 3 would be here. And as you can see, our sideways parabola is going to look like this, our inverse function. So I don't know whether you can see it or not, but it's actually a reflection along this axis. So every point's actually reflected along that axis.